This is question number 16B of year 2012 HSC mathematics paper. So I'll just write it down. It's 2012 HSC mathematics paper Q16B. So normally question 16 is the last question in the paper and it's the least attempted. Either it is hard or either students don't have much time. I'll be doing some questions from the past papers and some from trial papers in the future, especially for 2 units. So this is 2 units on mathematics. Based on the request, I might do mathematics extension 1 or extension 2 questions videos for it, maybe for general mathematics as well. So let's now focus on the this question. So this is a combination. This has in part B, this has 4 sub questions. It's combination of trigonometry, straight line, and also maximum minimum. So normally question 16 and most of the second part section 2 questions, they combine the things. So what you need to know under pressure, how do you handle this? I'll go through step by step. There can be other ways to do this, but I'll go through it slowly so you can pick it up. Normally you can find answers, but they are not self-explanatory sometimes. So okay, without further ado, let's jump into the question. Okay, so the question is about there's a diagram here. So there's a part circle with angle theta. The theta is 0 to between 0 and pi by 2. So the circle's equation is a unit circle, which is x squared plus y squared equals 1. So the radius of this circle is 1 here. And they're asking, okay, I'll read the question. Diagram shows a point T on the unit circle. So there's a point T here at angle theta from the positive x-axis, where theta is between 0 and pi by 2. A tangent to the circle, which is the PQ is the tangent to the circle at T, is perpendicular to OT. So that angle is 90 degrees here. That's 90 degrees. And it intersects the x-axis at P. And the line y equals 1 at Q, which is Q point. The line y equals 1 intersects the y-axis at B. So there's a lot of information at the first glance, but we don't need everything for the first part. Let's look at the first part. Show that the equation of the line PT is x cos theta plus y sin theta equals 1. So don't worry about the equation at the first sight. How did they come up to that? So we'll have to eventually build it. So one thing we know is OT is a straight line and it goes through the origin. So if you can find the OT equation, let's say that line has a theta angle, that's T, and that's OT. We don't need to find the equation of that angle, but the only thing we need to know is that the gradient here is M1, let's say, equals tan theta. That's the gradient of that line. Why do I need it? Because at T point, the circle here, at T point, there's a tangent. And that tangent has a gradient M2. If we want to find the equation of the line, we need to find M2. So what we know for a tangent at that point, the gradient of that is related to M1 by M1 M2 equals minus 1. So that way we can find M2 equals minus 1 over M1, which gives me M2 equals minus 1 over tan theta. You can keep it as either minus cot theta if you are comfortable with it, or you can expand this. You can expand this as minus 1 sine theta over cos theta, which also gives you your denominator here. You can readjust it to get minus cos theta over sine theta. So there can be different ways of writing M2. That's the one based on your preference. You can either keep it as cos theta if you are comfortable, or you can put it cos theta sine theta. Now okay, so we know the gradient of the line PT. Now I'll come to that side. Okay, now let me rewrite it. So we have a section like that. I'm writing only a part of it. P, T, this is O, this is theta. So we know now the gradient of this straight line M2. So that's known, so that's good. So how do you find the equation of this line? So the equation of this line will be in the form of y equals mx plus c. In this case it will be y equals m2x plus c. Now one thing we can do is we know t. If we know the coordinates of t, so let's say the coordinates of t is x1, y1, we can sub that x1, y1 here instead of y and x, and then find c. Once you find the c, we know all the unknowns in this equation, which we know m2 already, so we find c and then we'll be done. Now how do you find x1, y1? That's the question. Now that's a 90-degree angle. From this triangle OTP, if you look at that triangle which is having a theta, so we need to find x1, y1. This is the origin, right? So if you find x1, y1, let me write down, this is 1 because that's a unit circle that goes through here. So we know so this is T, this is P. And let me have another letter like capital A. From OAT triangle I can find OA. So my x1 would be OA. My y1 would be AT. So if I write down this triangle separately, O, A, T, 1, this is y1, this is x1. I'm trying to find x1 and y1. For this angle theta, I can write for this triangle sine theta is the opposite over the hypotenuse, then that is 1. So my y1 would be sine theta. So I know y in terms of theta. Same goes for cos theta. For this triangle will be adjacent over hypotenuse, which gives me x1 equals cos theta. Now for this line I know x and y1, so I will rewrite my equation, which is this one down here in terms of, so in that line it will be y1 equals m2 x1 plus c. Because I know y1 and x1, I can sub them in. Sine theta equals m2, which I already found before, which is minus cos theta over sine theta. I can do that too. Minus cos theta over sine theta. x1 is cos theta plus c. Right? Now I can rearrange the terms C equals, I'll take that to the side, which gives me sine theta plus cos squared theta over sine theta. So that leaves me with, when I rearrange this again, common denominator gives me sine squared theta plus cos squared theta, which is actually 1. That's from trigonometric rules. Sine squared theta plus cos squared theta equals 1. You need to remember those. Of course, if you are close to HSC max exams, you should remember them. So that is 1 over sine theta. So I know my C constant in the equation. What happens now is, if you rewrite the equation, y equals m2x plus c. I know m2 and c now, which means I have y as y, because I need to find the general equation, m2 as cos theta over sine theta, x plus constant, which is 1 over sine theta, which we just found. Okay, now we are almost there. Just rearrange the terms, times it by sine theta, everything. So I'm writing that step. Normally you don't need to, but I'm making it easier, so I times it by sine theta equals everything. Which you don't normally need to do. This is just to make things clear. If I don't know which level you are when you are watching this video, so I'm making it much easier. Then I get y sine theta minus x cos theta plus 1. Okay, almost there. We rearrange the term, so take this to the left, it becomes positive, plus, okay, y sine theta equals 1. That's the part 1 answer. So that's all that work gives you 2 marks. There might be some things that you need to write, but in generally I'm interested in showing you how to do the workings. Okay, now we'll have to go to the part 2 of the question, which is that's the part 2, find the length of BQ in terms of theta. Okay, now let me check if I can copy this over. Okay, let me take it down. Port image. Okay, I'm back in the, just copied this back. Yeah, so now we're in part 2 of this question. Now part 2, what do we have to do? Find the BQ, which is that length. Okay, now we know the equation of PT, which is good, which is from part 1, which is x cos theta plus y sine theta equals 1. Now that line intersects with BQ at point Q. So that line, that's Q. So this is our equation, and that's BQ. So that is the intersecting point. That means at that intersecting point y is equal to 1, which means we can add that up or sub it in our equation, which gives me x cos theta plus 1 sine theta equals 1. That gives me x cos theta plus sine theta equals 1. So we are rearrange the term, 1 minus sine theta over cos theta. So that's the length, the x coordinate actually. Now if you think about it, the x coordinate is actually the length of BQ, because that's from the origin. So that x coordinate you find is the length of BQ. So length, so length BQ would be 1 minus sine theta over cos theta. That will give you 1 mark. Okay, now part 3, getting there to the end of the question. Parts 2, part 3. Show that the area A of the trapezium OPBQ is given by A equals 2 minus sine theta over 2 cos theta. Okay, now what is this trapezium? Which is OPQB, which is, if I redraw it, my exceptional drawing skills, OPQB, pardon this, my straight line QP, but anyway, so I need to find the area of this triangle, trapezium. Okay, so how do you find a trapezium area? It should be fairly known by now for you guys who are doing the HSC exams, but to wrap things up or to make things clear, if this is A, this is B, this is H, let's say, the area of it would be H over 2A plus B normally. Okay, so I'll just erase that, that was just to remind you. Extra thick, just re-erasing it now, we don't need it. Okay, you don't need to write them in the exam. Okay, so in this case we need to find that length and H. Let's say this is A, this is B. Okay, the good thing is we already know H, because H equals 1, because if you look at here, that's y equals 1 line, which means this is 1. Okay, so you know H, good. That's good, but A, you know that because this is BQ, which you just found. What about OP? So how do you find OP? Let's look at how you find OP. Now from the OTP, that triangle here, if I rearrange it, not rearrange but redraw it, OTP 90 degrees, which is 1 here. So I won't find OP. This is a right angle triangle, so it's actually the hypotenuse of this triangle, and this is theta. So if I write sine theta for this triangle, so if I can draw it with a different, if I turn it around in this way, say OP, it is the same triangle, I'm just redrawing it. So TOP is that theta, that's OTP, and that's 1, and that's the hypotenuse I want to find. So basically cos theta for this triangle would be 1 over the OP. So my OP would be P1 over cos theta over sec theta. It's up to you how you keep it, but let's keep it simple that way. Now it's just about finding the area now, which makes it easier. H is 1 over 2 times BQ plus OP, right? So that means half BQ is 1 minus sine theta over cos theta plus 1 over cos theta, which is OP, which gives me half common denominator 1 plus 1 2 minus sine theta, 2 minus sine theta over 2 cos theta. Okay, that's the area, which is the answer as well. Just to show you, that's what we have to find, and that's what we found. So that's good. That's 2 marks here, and then we'll focus on the next part. What is the next part? Find the angle theta, subpart number 4. Angle theta that gives the minimum area of the trapezium. Okay, that gives us a clue. Differentiate, find the maximum minimum. So we not only have to differentiate and show stationary points, but we need to also prove this is a minimum area. Okay, let's do it step by step. New page. Let me write it down again. A equals 2 minus sine theta or 2 cos theta. Right. So if I have to differentiate this, which means A dash, I have to differentiate A in terms of theta, that is what my A dash is, because you can't differentiate with respect to x because there's no x in it. Okay, so if I do differentiate this, what I get is differentiation, which leaves me u as 2 minus sine theta, v as 2 cos theta. Actually, you don't have to have 2 because that's a constant. You can leave it out of the equation. So I'm leaving 2 out of the equation, or maybe just leave it 2. It doesn't matter. So u dash would be differentiation of this constant, differentiation 0. Sine theta differentiation would be cos theta, right? So v dash would be v dash would be 2, doesn't matter, it's a constant, cos theta minus sine theta. So that's a times, which gives you minus times 2 sine theta. Now differentiation of a division is u dash minus uv dash over v squared. So I have to just sub in these values, which gives me a dash. Okay, let me rewrite it. A dash equals cos theta, u dash is minus cos theta, minus u is 2 minus sine theta times minus 2 sine theta over v squared, which gives me 4 cos squared theta. Now this is minus 2 cos squared theta. So this minus that minus becomes plus 2 sine theta times 2 minus sine theta over 4 cos squared theta. That means we'll get minus 2 cos squared theta plus 4 sine theta minus 2 sine squared theta over 4 cos squared theta. So let's rearrange these terms. 4 sin theta minus 2 sin squared theta minus 2 cos squared theta divided by 4 cos squared theta. I'm writing too many steps here. Normally you don't have to. I'm just making it clear, doing it step by step. So I'm taking 2 out. That leaves me with sin squared theta plus cos squared theta over 4 cos squared theta. This is 1, which you should know by now. 4 sin theta minus 2 over 4 cos squared theta. Common factor 2 gives me 2 sin theta minus 1 over 2 cos squared theta. Now that is A dash. So what happens at a maximum or minimum or stationary points is A dash should be 0, which leaves me 2 sin theta minus. So I should write those steps. You should write those steps in the exam. I'm just not doing it because I'm a bit lazy to write all that. That gives me 2 sin theta minus 1 over 2 cos squared theta equals 0. That leaves me, because this is not equal to 0 anyway, it's a positive number, greater than 0 number, so you leave it 2 sin theta minus 1 equals 0, sin theta equals plus 1 over 2. So sin theta is half. So if sin theta is half and theta is in between, and theta is in between 0 to pi by 2, the only value theta can get would be 30 degrees, or which is normally we write it as pi by 6 in terms of radians. So the answer for this is theta would be pi by 6, but if you stop at that point you won't get the full marks, because this only thing that this shows is that theta at pi by 6 is a stationary point. It doesn't tell whether it's a maximum or minimum. So you need to prove it whether it's a maximum or minimum. There are different ways of doing it. One thing is just looking at the question. Say this question, we found the area, which should be the easiest way, area to be 2 minus sin theta or 2 cos theta, right? So let me rewrite that. Some area to be 2 minus sin theta over 2 cos theta. Now if I look at the area versus angle where theta is between 0 and 90, so pi by 6 would be 30. We don't know whether that's a maximum or a minimum. So if it's a maximum, it will go like that. If it's a minimum, it will be like that. Now how do I find if it's a maximum or minimum? Okay, let's just do it by looking at the question. So if theta equals 90, which I'm trying to find out here, then I will get A equals something over 2 cos 90. Now cos 90 should be 0, that means this goes to infinity. So area should go to infinity here. So that means around here it should approach, area should approach infinity. I don't know about pi by 6, but let me check at 0. A equals 0, 2 minus sin 0, which is 2, cos 0 1, which is 2. Value of area is 2. What I did was I just sub in theta equals 0. Theta equals 0, I did 2 minus sin 0 over 2 cos 0. So cos 0 is 1, that's 0. So that leaves me with 2 over 2, which is 1. So that's 1. So there's a stationary point in between 0 and 90, which means, so that should be either maximum or minimum, but since this is infinity, so that should come down and go up. So that should be a minimum here. That's one way to do it, which probably is the easiest way. So that's normally concludes your answer there. But okay, if they ask you to find the minimum area, let me check if they ask you to do that. Now they only ask for the angle which gives the minimum area of the trapezium. Now if you don't do it this way, you can do it in a different way, but it's a bit lengthier. What you will get is you find your a dash, which is this. You need to differentiate it again, which means let me copy this. Copy this and then paste it, I think. Doesn't work like that. Yeah, was I? Okay, I just delete that. And then what we got was 2 sine theta. 2 sine theta minus 1 over 2 cos squared theta. So you can differentiate this again, which is I'll just remember this and then write it back down. A dash is 2 sine theta minus 1 over 2 cos squared theta. You can double differentiate this and show that this is greater than 0 at theta equals pi by 6. That will give you theta to be, area to be minimum, because at a minimum you have a double dash, which is the second derivative, greater than 0. So how do you do that? You need to double differentiate this a dash, which is time consuming. I don't recommend this, but just to show that this question can be, that this is a minimum, can be proved in two different ways. Should be, so you have to take this as u, this as v again, and then double differentiate it. Okay, let's do that. So my u would be 2 sine theta minus 1, u dash would be 2 cos theta, v would be, I'll just take cos squared theta, doesn't matter. V dash would be differentiation of cos squared theta, which is minus 2 sine theta cos theta. If you are a 3-unit student, you know that, but if it's a 2-unit mathematics student, you need to do this again as a uv multiplication, which is cos theta cos theta. Treat t as cos theta, v as cos theta. When you do that, you'll get to this. Now what we need to find is a double dash at theta equals pi by 6. So we have to find that theta equals pi by 6, u becomes 2 sine pi by 6. Okay, let me write down, u becomes 2 sine pi by 6 minus 1, u dash becomes 2 cos pi by 6, v becomes cos squared pi by 6, v dash becomes minus 2 sine pi by 6 cos pi by 6. So that is, u becomes sine 30 is half times 2, 1 minus 1, 0, u dash 2 times root 3 over 2, which is root 3, v equals cos squared 30, which is root 3 over 2 squared, which is 3 over 4, v dash is minus 2 half root 3 over 2, which is minus root 3 over 2. Why do we need that? Because we are putting a double dash as v dash u minus uv dash, sorry, dash over square. Now we have v dash minus root 3 over 2 u as 0 sorry, that's a, so this has to be written like, so we get vu dash minus uv dash over v squared. So we have v as 3 over 4 u dash root 3 minus u0 times something, doesn't matter because it's 0, and then you have v squared, which is a squared, and that means this is a positive number, this is a positive number, so you have a positive number for a double dash which is greater than 0. So that's a maximum. That just says a double dash is greater than 0, that means a dash is a minimum. Now the whole part that I did later after showing it theoretically, which means after here, you don't have to do it, it's just to show that you can do it in different ways. Now I hope you understand the question clearly. I did a lot of steps which you don't need to do if you are quite good at solving some like steps like here. You can do it and skip couple of steps, come down here, which I would normally do in a question exam, but yeah, this is to show you how to do them. Like depending on your level you can grasp it. So if you like the video, like these videos in the YouTube channel, you can subscribe to it, and I'll also put the Twitter link. You can follow me. I'll be putting more videos of 2 units or mathematics questions from exam papers and trial papers, and you can click in the link below if you want to arrange a private tutoring lesson. I'll show the contact number or the email in the below link, or you can see it in the YouTube description as well. Okay, so for now the question 16b is done. We'll do more questions in the coming few weeks. Okay, see you.